Hello, welcome. Today I am going to discuss about the uh, real gas Vanderwaals equation. Okay, so we have PV is equal to nRT or PVM is equal to RT. This is the ideal gas equation. So we know that in the ideal gas condition we had assumed that gaseous molecule there is no intermolecular force of attraction, and also we assume that gas molecules are very tiny, and we neglected the volume of the molecules compared to volume of the container. Okay, so here in the Vanderwaals equation, the ideal gas equation has been modified by Vanderwaals by introducing the two corrections, that is volume correction and pressure correction in the ideal gas equation. Okay, so let us see what are those things. Okay, Vanderwaals modified ideal gas equation one correction due to volume of the gas molecule. That is volume correction. Okay, so that is volume of the gas molecule should not be neglected. You know that even though molecule of the gas have definite volume, we have neglected, that is, suppose this is your volume of the gas. Let me explain you. So suppose some gas is present in this container. Okay, so for example, I am a gas molecule, and this room is the volume where I am present, or gas molecules are present in this room. So according to gas kinetic model of the gas or ideal gas concept, the gas molecules can move all space available, that is, I can fly all the room space available in this room. I can go everywhere in the room, but I cannot go within me where I am present. You got it? So Vanderwaals says that this volume should be equal to volume of the container minus the excluded volume or volume of the gas. Okay, so that is I hope you got it. These gas molecules can move all space available, but not the in the gas molecules. Every things will have a definite volume. They cannot move. They have already occupied that. So that space cannot be moved. So that space must be reduced. Simply, this is what the volume corrections mean. Okay. So Vanderwaals into volume of the gas which is compressible, or volume of the gas which is compressible, is equal to volume of the gas which is compressible is equal to V minus NB. That is V is the volume of the container, and B is the excluded volume. B is Vanderwaals constant, okay, excluded volume. So, that is depend on the molecules to molecule, depend on molecules to molecule. Okay. So, let me elaborate the excluded volume, how it is related to the actual volume of the molecule. Okay, excluded volume is the actual volume of the molecule actually. Let us discuss. This is gas molecules, they are close to each other, and you know that this is actually excluded volume. Excluded volume, that is what is the distance between this, say this is D, how it is related, D is equal to 2r, that is radius of the excluded volume, radius of the excluded volume D is equal to 2r. Okay, that is excluded volume, that is volume is equal to, so excluded volume per molecule, is equal to, because this is, you see, this is for 2 molecules, so you can say that 1 by 2 into 4 by 3 pi d cube, that is, you can say that 2 by 3 pi d cube. This is excluded volume per, this is actually B. Okay, excluded volume per molecule. B is equal to 2 by 3 pi d cube. So, again let us consider actual volume of the molecule is equal to actual volume is 4 by 3 pi r cube. Suppose the r is the radius of the molecule, or r is the radius of the and d is the radius of the excluded volume. Okay. Excluded volume. So, we can say that now you put the value of D here, that is actual volume is equal to 4 by 3 pi r is equal to d by 2 cube. Okay, that is 4 by 3 pi d cube 8. This can be written like this, 2 by 3 1 by 4 pi d cube, right. I am just rewriting this simply for getting some relation, that is 2 I have taken 2 here. So, if I am cancelling the 2, it will be the 4. So, this is what, that is 1 by 4, this is excluded volume, this is excluded volume, right. That is actual volume of the molecule is equal to actual volume is equal to 1 by 4 into excluded volume. That is excluded volume is equal to 4 into actual volume. Simply I can say that excluded volume is equal to 4 into actual volume of the molecule. So actual volume is equal to 4 into excluded volume is equal to 4 into actual volume of the molecule. So this is all about the excluded volume and actual volume. Okay. So excluded volume per mole will be what? Excluded volume per mole, that is for n mole, that is Na into 4 into 4 by 3 pi r cube, right. Have I got a number? That is the V ideal in the ideal gas equation should be replaced by V real, that is the volume of the container, okay. So minus NB, okay. So ideal volume should be replaced by actual volume of the molecules minus actual volume of the container minus volume of the or excluded volume. This is the first corrections did by Vanderwaals. Okay, so this is the volume correction. Okay, next is pressure correction. So what is the pressure? Pressure is the force per unit area. So you can say that we have assumed that in the ideal gas there is no intermolecular forces of attraction between the gas molecule, but actually you know that there are the intermolecular force of attraction. We will discuss later what temperature, what pressure, like there are these conditions, but if gas molecules do not have in any temperature or any pressure condition, if there is no intermolecular force of attraction, means gases cannot be liquefied or it cannot be solidified. Okay, so gas molecules do have intermolecular force of attraction. So intermolecular force of attraction should be considered, that is force is related to the pressure. So the pressure correction is related to the intermolecular force of attraction. Correction due to second correction due to intermolecular force of attraction. Correction due to intermolecular force of attraction. So ideal gas ideal concept says that no intermolecular force of attractions, that is although it is not like that, the actual pressure due to, again let me again consider the picture. So, in the what is the pressure of the gas? Pressure of the gas is due to the collision of gas molecule to the wall of the container, inner wall of the container. That is why pressure of the gas. Okay. So, if there is an you are neglecting the intermolecular force of attraction, which means that there is intermolecular force of attraction between the gas molecules, means this pressure is pulled back, or the pressure experienced in the gas molecule has to be considered intermolecular force of attraction between the gas molecules. So, that term is introduced. Okay. So, you can say that that is what the pressure correction in short. Okay. Correction due to the pressure, the actual pressure, experienced pressure is less than there is some more pressure term is used for intermolecular force of attraction. Okay, in terms of intermolecular force of attraction. So, that is the actual pressure due to collision of the wall of the container is lower than if there is no force of attraction. If there is no force of attraction. Okay. Again, we know that pressure is related to the, simply I can say that the pressure is simply related to the density of the gas. Again, simply I am relating. Again, density square. Okay, pressure is directly related to the density square. Okay, mass by volume. Okay, and pressure, that is pressure is related to the density is related to the mass by volume, that is it is directly proportional to 1 by v square. Okay, and that is P is equal to, okay, pressure of some pressure that is E 1 by v square. Okay, so this A depend on, where A is A depend on intermolecular force of attraction. Okay, A depend on intermolecular force of attraction. That is the P ideal in the ideal gas equation should be the P real, the experienced pressure P real, okay, plus A by Vm square. This is the equation number third. First equation is the PV is equal to nRT or PVM is equal to nRT, and second equation is so I hope you wrote it, Vm is equal to Vm ideal real minus B, and this is for your equation number 3. This is 2, this is 3. Putting all together in the previous equation, P plus A by Vm square V minus B is equal to RT, or this can be also written like this: P plus An square V square V minus Nb is equal to nRT. So this is all about the Vanderwaals equation. Our A and B are the Vanderwaals. Generally we can say the A and B are Vanderwaals constant, or that we can also say that A related to the intermolecular force of attraction and B related to the excluded volume. So I am stopping right now. Will have more discussion on the next class about this equation itself. So some condition we have to discuss some conditions and how this equation is changing. So we'll see in the next class. Bye.